Good morning to all. Today we will start talking about a different perspective of the memory system. So, that is something called memory interleaving. Basically, it deals with, say, suppose we have a different type of memory module, say suppose we have a n memory module. So, now how do you make a single memory system, so that data can be accessed so easily. So, that we will talk about. So, maybe we can put the heading is like memory interleaving, book is amateur. Okay. So, as you know that CPU generate the address of the main memory. Okay. So, suppose we have the memory module here. Memory module will have two important register. One is called ABR, address buffer register, another is data buffer register. As you can understand from the name, that is the address buffer register basically identify that which location in the main memory of this module needs to be accessed, and once data is available, data will be put into the DBR. This is another register. So, suppose we need to have location from here. So, this data or this word should be placed into the DBR. Similarly, let us say we have 4 memory module, and each memory module had obviously have a address buffer register and data buffer register. So, address buffer register and data buffer register, address buffer register and data buffer register. Okay. Now, so if CPU generate, let us say for simplicity, there are two mechanisms that one can access the locations or the memory words in two ways. So, let us take one example. Let us say there are n bit address. Okay. So, there are, so let us say k, this will be n minus k. So, this is most significant bit and this is least significant and this is most significant part. Okay. Now, to identify a location, we can use location within a module, we can use the least significant portion or we can use the most significant portion. So, one example will be good. Let us say in the each memory module we have 4 location 0, 0, 0, 1, then 1, 0 and then 1, 1. Similarly, here 0, 0, 0, 1, 1, 0 and 1, 1. Similarly, here 0, 0, 0, 1, 1, 0, 1, 1. Similarly, 0, 0, 0, 1, 1, 0. Okay. So, now, so if the lower order, not lower order significant bit, that is lower order bits are used for identifying location within a module. So, that means, say this lower order will identify here the location within the module, whereas higher order will form identified that location in which module. Okay. So, now this will be connected here, this will be connected here, this will be connected here. So, and then higher order memory module, higher order will identify which memory module. Let us say we have 4 modules and each module has 4 locations. So, therefore, total entire memory module will have 16 locations. Then how many bits? 4 bits. Okay. So, out of this 4 bit, so 2 bits will be used for identifying the location within the module and then rest will be used for identifying the any one of the modules. Okay. Let us say we want to access 1 0 1 1 and next we want to access 1 0. So, if you add it, it will be 1 1 0 0, next is 1 1 0 1. Now, you see within 1 0 1 1, that means 1 0 1 1, this will be the module, right, this will be the module 1 0. So, 1 0 module is, let us say this is 0 0, this is 0 1, this is 1 0 1 1. So, 1 0 module is say this one and then last is 1 1. So, that means I want to say this is the location here I want to access. Similarly, lest you see that is 0 0 0 1, this consecutive location apart from the last location all will be in the same memory module. Let us say 1 1 0 0, 0 0 will be here and 1 1 will identify the this 1 1, that is the higher part of the significant bit will identify the module. So, therefore, 1 1 0 0 will be this part and 1 1 0 1 will be. Okay. So, this is one style where actually it is not possible to have parallel the two memory module cannot work parallelly, because whenever that processor most of the cases it accesses the consecutive memory location. As you can see, the consecutive memory location here it is 1, another is 1. So, consecutive memory location, if it is consecutive memory location is here, two cannot access at the same time, but obviously this is and this is can access parallelly. Okay. So, this is one style where lower order is used to identify the location within the module and higher order is used to identify the module. So, now we will have the another organization of the memory with the same example here. See what we did it here, we have a module 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 here, and then let us say 1 2 3 4. So, this is ABR, DBR, ABR, DBR, ABR, DBR, ABR, DBR. Okay. So, now we have a memory of let us say n bit. So, this is k bit and this is n minus k. Now, it will be reversed. N minus k module will be used to identify the location within the module. So, therefore, this will come here and this k bit will identify the module. Now, what will happen? Let us say I want to access the memory module 1 0 0 0, 1 0 0 1, 1 0 1 1, 1 0 1 1. So, then this lower part is what? Lower part will identify the memory location. So, 0 0, sorry, lower part will identify the lower part, this is lower part, it will identify the memory module. So, that is memory module is 0 0. So, this is 0 0 0 1 1 0 1 1. So, this is 0 0 0 1 1 0 1 1. So, these all will be the in different memory location, and within the memory location this will identify the which location. This is this module within this is 0 0 0 1, this is 1 0 1, this is 1 0, this is 1 0, this is 1 0, this is 0 0 0 1 1 0 1 1. Okay. So, therefore, now what happened, these all locations here, these locations are in different memory module. So, they can work parallelly. So, while reading from here to and placing it here, this can go parallelly, this can go parallelly, this can go parallelly. But if it is from the same memory module, so two location data cannot be placed in a single register. You need to have the two register in that case, but we have only one single register in this module. So, this structure is called the memory interleaving. As you understand that this work can, these 4 block it can be read parallelly, while it is reading from here to here, at the same time it can read and this can read. Okay. Now, what we learn it here, this is one organization, this is one organization, right. Now, what we do it, we will take one example and we will show you how much faster, for as you understand this will be much faster than earlier one, right. That we will see with one example here. So, example, let us say cache block size is 8 words. Okay. One cycle is required to send main memory address from CPU to main memory. So, one cycle is required to send main memory address from CPU to main memory. Okay. So, 8 clock cycle for accessing the first word in a module. So, 8 clock cycle for accessing one word or first word first word in a memory module, okay, and then 4 clock cycle for accessing subsequent, okay, 1 clock cycle for sending data, sending one word from one cycle from sending one word to cache from main memory cache, okay. So, question is find the time in cycle, find the time required to send one block from main memory to cache memory, okay. So, then block means one word. So, once address is generated, it will take one cycle to send main memory address from CPU to main memory, 8 clock for the first word in the module, and subsequent word will take only 4, 1 clock cycle for again from sending from memory to the cache memory. So, if you go back here, so it is saying ki from accessing first word from here to here it is taking 8 cycle, but if it is the within the module it will take again 4 cycle from here to here, but after placing the word from here to cache memory it is taking 1 cycle. So, that is why it is said ki 1 cycle for sending one word from the main memory, and for sending the address it is taking 1 cycle. So, now question is if you want to send one word, sorry, if you want to send one block from main memory to cache memory, what will be the total number of cycles, okay, if the memory is assigned into the both strategy, that is in the first is with non interleaving and second one is interleaving, okay. So, this is the problem. So, in first case is non interleaving organization, okay. So, what will be the time? Time first is CPU will generate one address, okay. So, starting address, okay. So, first case starting address means we have memory module, and then memory module will have size more than one block obviously. So, one block has to go from main memory to cache memory. So, first is the address needs to send, so that is one cycle. Then in the memory block, so this is ABR and this is DBR. Now, data will be passed from here to here, so therefore 8 cycle. While passing data from here to here, at the same time data can be transferred from here to here after placing it here, and subsequent all memory location within the module. So, this will take 4 cycle, and that also needs to be transferred here after placing this one. So, everything will go parallelly from transferring data from here to here and just reading data from here to here, that can go parallelly because it is a reading operation. So, therefore, time will be 1 plus 8. So, first and then subsequent it will take while transferring from here to here. So, data can be read from here to here before placing, because this one will take 8 clock cycle, sorry 4 clock cycle. So, then 7 another word 7 into 4, and then after placing here it will take 1 cycle. For the last block it is taking 4 cycle, right, okay. So, before the last block while placing it here at the simultaneously this will go parallelly, but last block, that is the last word, once you place it then only it will go up, okay. Therefore, for last 4 will take another, sorry, last one will take one more cycle. I repeat it. So, first is for sending the address, then first was it 8, second word it will be again 4, and while reading 4 then 8 can be transferred, that sorry, this is a single word only, one word will be transferred, it is 1. So, 4 is more than 1, so it can be done parallelly. Similarly, second will take and then 7 will be placing. So, when the last word will be placed, so that again needs to transfer. So, this is the for the last word, and this is for the 7th word in the module, and this is the first word. So, this total will be how much? This will be 38 cycle. Now, if you have, let us say if you have interleaving structure. Okay. So, then what will be the case? So, interleaving structure means now no need to access from the same memory module, it can be accessed from the different memory module. Okay. And you have 4 structure, right, 4 memory module. So, therefore, what we can do it here. So, time will be 1 for sending the starting address, and 1 word means, so this is 4 word, this is 4, and then this is another 4 consecutive 4 within this module. So, this will take from the first module, this is second module, third module, fourth module. So, for each one it will take 8 cycle, and then this one take, because it is within the module. So, it will take 4 cycle. So, first is sending the address to the all, first if you see here. So, this diagram sending the address to the all memory module. Okay. So, this is 0001 1011, this sending this address, because it will say the starting address, that is 1011, and then after starting address it will say that it wants to access the 8 location. So, you will have the 8 location here. So, therefore, what will happen here, it will take time 1 plus 8 for each of the blocks, for each of the module, first word. So, this is for the first word. Now, it is placed here, now it will take another 4. Why another 4? Because it is the second word and they are working parallelly to the individual DBR, and while transferring data from here, it is taking transferring, that is 4 cycle. After 4 cycle data will be available, at the same time this can transfer happen. So, therefore, this will take only 1 cycle. So, this will take 4 cycle, because there are 4 memory module. So, then this is 4 for reading from here to here, and once you place, for the each module will have the 4 words, right, each module will have the 1 word. So, that is there are 4 modules, so 4 words. So, now these data needs to transfer from here to the main memory. So, therefore, this will be another 4. So, this total will be 17 cycle. As you understand, if you do not use interleaving, then it is taking 38 cycle, if you use, then it is taking 17 cycles. Okay. So, with this I stop here.